In this video, we're going to do an example that involves the hypergeometric distribution. In fall of 2021, of the 50 United States, 41 of the 50 governors were men. And of these 41 men, 17 were Democrats. So for part A here, we're asked if 5 governors are selected at random, what's the probability that the selection will have 4 men and 1 woman? So we need to figure out the number of ways to select 4 men and 1 woman, and then divide by the number of total selections of 5 governors. Well, the total number of selections of 5 governors for our denominator here would be, we have 50 total governors, we're going to choose 5 of them. So 50 choose 5 will be our denominator. For the numerator, we can think about it breaking it into tasks. We can choose the 4 men and then choose the 1 woman. For the 4 men, we have 41 possibilities to choose from, where we're going to choose 4 of them, so we have 41 choose 4. For the 1 woman, we could just write this as times 9, but it's 9 women and we're going to choose 1 of them. And then again, since we're doing 4 men and 1 woman, since we have an intersection here, task 1 followed by task 2, this is a multiplication principle, we'll multiply those 2 together. And if we simplify, we get approximately 0.43 for the probability. All right, so let's look at part B here. We're going to just reduce our sample space to just the male governors, where again we're going to select 5 at random, and now X is going to be the random variable that represents the number of Democratic governors selected. We're asked to find the probability mass function for X here, and to identify the support for X. So this is an example of a hypergeometric distribution, because we have our sample space divided into 2 disjoint groups, and we're doing a selection from the entire sample space and looking to count the number that are in one of the groups. So we know there are 17 Democrats that we're trying to select from, and that's what X is counting, the number of Democrats. So we'll have 17 choose X for the number of number of Democrats in the sample. Well, if it's not a Democrat, then they're a Republican. So out of the remaining 24 governors, we'll have choose 5 minus X of them. And then just like in the previous part, the total number here will be our total number of male governors, which is 41, choosing 5 of them. So this is our PMF in this case, and we recognize that it is a hypergeometric PMF here. We're asked to find the support. Well, we can either pick 0, 1, 2, 3, 4, or 5 Democratic governors from the group of 17. Male governors, I should say. All right, so for part C now, let's see if we can use this probability mass function to answer the question. It says, what is the probability that there's at least 1 Democrat in the selection of 5? So we're being asked here to calculate the probability that X is greater than or equal to 1. It's much easier to do the complement in this case. Since it's a discrete random variable, the complement of at least 1 is none, or no Democrats in the selection. So this will be equal to 1 minus the probability that X is equal to 0. Using X is equal to 0 here, we'll get 1 minus 24 choose 5, because 17 choose 0, of course, is 1. So we'll have 24 choose 5 over 41 choose 5, which is approximately 0.943. Finally, we're asked to figure out what the mean and the variance are for X. Again, X is a hypergeometric, so your mean for a hypergeometric is number of elements in the sample times the number of elements in your category that you're trying to count, if you will. So in this case, 17 over the total number of possibilities in your sample space is just 41. Or in this case, approximately 2.073. For your variance then, it's n, which is 5 in this case, your sample size, times the number of elements that you're trying to count over the sample space, so the 17 over 41, your number of the things that are not in the things you're trying to count, so in this case 24 over 41 over the sample space, and then that last part will be total number minus number of selections. So in this case, total number is 41 number of you're selecting is 5, so this is 41 minus 5, that's where the 36 comes from, over total size of the sample space minus 1, or 40. And if you simplify this in this case, you'll get 1.092.